All right, today we're going to look at Venn diagrams. And Venn diagram is a picture where we're dealing with two circles, and these circles are representing different categories. And to break this into context, this circle represents the people who are taking a statistics course, and this circle represents the people who are taking an accounting course. And so when we look at a Venn diagram, the first thing that we want to do is we want to come up with a total. And the easiest way to come up with a total is just to add your four numbers. So 7 plus 3 plus 6 plus 4, the total is going to be 20. And it's important to get that total correct because that total is going to represent your denominator in most of your answers. So the first question, and again we use P for probability, the probability that you are taking a statistics class. So when I look at this whole circle, okay, there are 10 people out of the 20 people who are taking a stats class. So 10 out of 20 would be our answer for that one. The probability that you are taking a accounting class, in that whole circle there are 9 people. So that would be 9 out of 20. Now this next little symbol, that little C there, is called the complement, which basically means the probability that you are not taking a stat class. So if I covered up that stats circle, okay, how many people are not in a stat class? 10 out of 20. And what should make sense is that if I look at these two probabilities, the probability that you are in the class and not in the class should add up to 100%. So for number 4, the probability that you are not in an accounting class, well, 9 people we said were in an accounting class. Again, if I cover up that circle, there are 11 people left who are not taking an accounting class. And again, those two numbers, the 11 and the 9, add up to 20 out of 20, add up to 100%. So the complement of the event means the probability of it not happening. Okay. Now the next two types of questions we have are what are called an or and an and question. We're going to take the and question first because that's the easier of the two. Okay. This is basically saying what people are taking stats class and accounting class at the same time. Okay. And that's the intersection of the two circles. So that one would be 3 out of 20. Now, the probability that you're taking an accounting class or a stats class means you could be taking either one. So we're going to take that probability of accounting, which we already have said is 9 out of 20.
Ms. Krebs and Jen Scott, please call the main office.
Plus we're going to take the probability of a stats class, which is 10 out of 20. Okay, but what we're going to notice here is that we counted that intersection twice. Okay, we counted the 3 when we counted the accounting class, and we counted that 3 when we counted the stat class. So we can't count twice, we have to subtract 3 away. So that 19 out of 20 minus 3 is going to be 16 out of 20. So the probability that you're in that class or an accounting class is 16 out of 20. Okay, common mistake people make is they forget to subtract that 3 away. Okay.
Can I use your phone? Or is it over here?
Video. For number 7, the probability that you are in a stat class given you are in an accounting class. Okay, so this symbol here, this slash symbol, we read that as a given statement. So again, I'm going to write this one out. What is the probability you are in a accounting class given you are in a stat class. Okay, so we're going to start with that given condition. And I'm sorry I didn't show you what I wrote there. Okay, what is the probability you are in an accounting class given you are in a stat class? So we're going to focus on the given condition. So when I look at my circle, okay, I'm only focusing now on that stats circle. Okay, I'm only focusing on this circle right here, which means I'm only focusing on 10 people. So this is where the denominator changes when we do a conditional probability. So of those 10 people, how many of them are also in an accounting class? Well, it's the intersection. Okay, 3 out of 10. Now if we flip it around and we say, when you're in an accounting class, well, how many people are in the accounting circle? 9. And of those 9 people, how many of them are also in a stat class? It's still the same section. It's still going to be 3. Okay, the only difference between those two problems is the denominator is going to change. The numerator is always going to be the same. And the reason being is, if you wanted it as a formula, the numerator is always going to be the intersection of the two, and the denominator is going to be whatever is the given case. In this case, it was accounting, that's why it was 9. In number 7, it was stats, that's why it was 10. So with a conditional probability, we don't use that total of 20 anymore. Now for number 9, the probability that you are not in an accounting class. Okay, that's the given condition. So if I'm not in an accounting class, I'm going to cover that up. Okay, I'm going to cover up the accounting circle. And there are 11 people who are not in an accounting class. Now, of those 11 people, how many of them are also in a stat class? Well, 7 of them. Okay, so not in an accounting class. Okay, 11 people. And of those 11, how many are in a stat class? 7. And for the last one, if we flip it around, the probability you are not in a stat class. Okay, there are 10 people who are not in a stat class, not in the stat circle. Of those 10 people, 6 of them are in an accounting class. So with a Venn diagram, okay, which we are going to practice a lot in this class, it can get a little tricky, but what you want to remember is that anytime you're dealing with a probability without a slash, without a given condition, your denominator will always be your total. It's only when we talk about these conditional probabilities, okay, where we're using that slash, that given symbol, then we are basing it on just that condition when we're looking at a Venn diagram. Okay, so again, good luck on the practice exercises, and hopefully this video helps you out in understanding Venn diagrams.